Very good afternoon. So today in this video, I have taken the topic of thermodynamic air cycles. So the thermodynamics air cycles concept is very much important. So for the diploma students as well as engineering students. So here, what do you mean by thermodynamic air cycles? The air standard cycles is a thermodynamic cycles in which a certain mass of air is used as a working substance throughout the cycle of operations. So what do you mean by that? Means if a certain quantity of mass of air in any engines is used as a working substance throughout the cycle of operations, so then the air standard, cyc- air standard cycle concept should be appear. So here the main concept of the air standard cycles was developed to carry out the analysis of heat engines. So here the air standard cycles is also called as ideal or theoretical cycles, by which reference of which a practical heat engine's performance can be analyzed and compared. So the air standard cycles is also called as ideal cycles, and engines, if it works on ideal cycles, the engines is called as ideal engines. So this is about a brief introduction about the thermodynamic air cycles. So there are different types of thermodynamics air cycles are carnot cycles, Otto cycle, diesel cycle, and dual combustion cycle. So these are the common air standard cycles. So for the diploma students and as well as the engineering students is very much important. So in this video, I have taken a carnot cycle first to explain. So to explain about the carnot cycle, I have some images. Through the image I'm explaining. So first, what do you mean by carnot cycle? A carnot cycle is a theoretical or a thermodynamic cycle. Mainly this cycle was introduced by Nicolas Leonard Sadi Carnot in 1824. He is a French engineer. So if the engine, if it is works on Carnot cycle, so then the engine is called as Carnot heat engine. Carnot cycle heat engine. So now let us discuss about the working of carnot cycle. So mainly the carnot cycle, it is consisting of four different processes as shown in PV and TS diagram. Let us consider a mkg of air present in the cylinder at initial condition represented by 0.1 as shown in PV and TS diagram. So the four different processes involved in carnot cycle, let us discuss as below. So here you can see the PV and TS diagram of carnot cycle. Below the PV diagram, you can see a cylinder. So this is a cylinder portion. So this is a piston when it is in resting at TDC position. So when the piston moves to the during the process 3 to 4, when it reaches the point 3, so the piston position is represented as BDC. So this is a insulating cap. So here you can see the heat source to heat the air from where the heat should be supplying. So this is a heat sink at T1, TL, and heat source at TR. So this is a cylinder portion. This is cylinder head of one. Now first let's start with the working of Carnot cycle, process 1 to 2. So iso expansion process, isothermal expansion. The air in the cylinder starts to heated by bringing the a hot source in contact with the cylinder head. So once the heat source bring into the contact with the cylinder head, the air in the cylinder is absorbs the heat and starts to expands. So when the air by absorbing the heat and is subject to expands, So it makes the causing the piston to move from TDC to towards BDC. So that is from volume V1 to V2. So here you can see this is volume V1 and V2. So during the process 1 to 2 isothermal expansion process, the heat it should be supplying to the air. So that is heat supplied equals Qs P1 V1. So P1 initial pressure of the air at point 1 into volume of air V1 into ln of increase in volume of air. So means from V2 to V1. So that is ln of V2 by V1. So therefore heat supplied Qs is equals to P1 V1 ln of V2 by V1. Under ideal conditions, we have the expression PV is equals to MRT. So that is during the process 1 to 2, it is applying P1 V1 at point 1, P1 V1 is equals to M1 T1. So therefore Qs is equals to, in place of P1 V1, it will become as MR T1 ln of V2 by V1. So take it as equation number 1. Next, the process 2 to 3, adiabatic expansion process. The heat source from the cylinder head, it is removing, and the insulating cap is in bond contact with the cylinder head. The air starts to expand adiabatically from volume V2 to V3 with the falling temperature from T2 to T3. So here you can see the air will be subjected adiabatically from volume VD to V3. So with the falling temperature T2 to T3. So during this process, the piston, the position should be at point 2. So during the process 2 to 3, the piston moves to BDC, completely to reaches the BDC position after completion of the adiabatic expansion process. So during the process 2 to 3, there is no heat transfer. So that is, we know that for adiabatic process, heat transfer Q is equals to 0 and T2 by T3 equals V3 by V2 whole power gamma minus 1. Take it as equation number 2. Next process is 3 to 4 isothermal compression process. The insulating cap is removed and a cold body is in contact with the cylinder head. The piston moves in upward, causing the compressing the air present inside the cylinder. So from volume V3 to V4. So what is the meaning means? During the process 3 to 4, so the air present in the cylinder, the piston starts to move from VDC towards TDC in the upward direction. So when it is moving, so it is compressing the air. So when it is compressing the air, the heat present in the cylinder, so the cold body is in contact with the cylinder head, completely it absorbs the heat from the air. So during the process 3 to 4, it is heat rejected. So here, if you observe in the TS diagram, the process 3 to 4, they are shown as heat rejected. That is QR equals P3 V3 at point 3, the volume of air and pressure, P3 V3 into the increase in volume of air, that is from V3 to V4, P3 V3 into ln of V3 by V4. Therefore, heat rejected QR is equals to, under basic conditions, we have at point 3, P3 V3 is equals to MRT3, that is QR is equals to MRT3 ln of V3 by V4. So take it as equation number 3. Next, process 4 to 1, adiabatic compression. The cold insulating cap, so cold body is removed from the cylinder head and insulating cap is brought in contact with the cylinder head during the process 4 to 1. So that is adiabatic compression process. The air starts to compressing adiabatically from volume V4 to V1 with the increase in temperature T4 to T1, and the piston moves to TDC as shown in figure. During the adiabatic compression process, the heat transfer is completely zero, so that is heat transfer Q is equals to zero. Therefore, Q T4 for T1 is equals to V1 by V4 power gamma minus 1. Take it as equation number 4. So this is about the working of Carnot cycle of 4 different processes. What is the air standard efficiency of Carnot cycle? So there is a small derivation. So we have the formula: air standard efficiency is equals to work done by heat supplied. Work done by heat supplied. So there is work done means heat supplied minus heat rejected divided by heat supplied. So heat supplied Qs minus heat rejected Qr divided by Qs. So Qs common, it will get cancelled. 1 minus Qr by Qs equals what is Qr and Qs. Writing the expression. So after writing the expression, take it as equation number 5. So that is 1 minus mr T3 ln of V3 by V4 divided by mr T1 ln of V2 by V1. So for Carnot cycle, compression ratio V3 by V4 equals expansion ratio V2 by V1. So based on this condition, so here, so V3 by V4 when it is equals to V2 by V1, it should be get cancelled. So then mr it will be get cancelled. What is the remaining term in efficiency of air? 1 minus T3 by T1. So here, therefore, equation 5 becomes air standard efficiency equals 1 minus T3 by T1. So another expression for air standard efficiency equals 1 minus TL by TH. What is TL? What is TH? Where TL is equals to T3 equals T4, lowest temperature of the cycle. TH is equals to T1 equals T2, highest temperature of the cycle. It is represented in TS diagram. If you see here, during the process 1 to 2, the temperature is constant because isothermal process. So T1, T2, it will be having highest temperature during the process 1 to 2. The process 3 to 4, so it is also isothermal compression process, temperature will be constant. So but the temperature it will be lowest at these 2 points, 3 and 4. It is noted denoted as TL. T3, T4 equals TL. So this is about the Carnot cycle. So I think hope you all utilizing this video. So thank you for watching my video.